for here. Once you figure that out, once you see what is trying to be created, think about what is being used to do that. How does it start out? And then is it a simple process? Are there a lot of things going on? Then we'll take a look at the actual questions at the bottom. First, we need to understand, what is this picture? All right, so let's start out. What is the end goal of this picture, of this diagram? A coal-fired power plant. What is the end goal? Create energy. Good start, Tobias. Now, we have our 7 different forms of energy. Someone other than Tobias, since he started us out with it, what kind of energy are we trying to produce here? What does this show? Morning, sir. Make sure you grab your papers. So someone other than Tobias, what energy is trying to be created? What is the type of energy which is the output?
Fourth one.
What was it, sir? Fourth one? Electrical? Awesome. So the fourth one on our sheets are electrical energy. So we're trying to get out of it electricity, the things we use all the time. Right? Electricity, which we run through all of our buildings. We use to do most everything in our daily lives in this age. Good. So we look at it, we see here at the end we've got electricity coming out into our power lines. What is being used at the start to create that electricity? Coal. So we're starting out with our coal supply. And we end up with electricity. Good. So, if it starts with coal, and this is the first question, if it starts with coal, which has lots of energy in its bonds between carbon and hydrogen, what type of energy are we starting with here? We're getting to electricity at the end, but what are we starting with? So I've got Monteau down, I've got Tobias down, someone else. What kind of energy is the energy that is stored in the bonds? If you're having a hard time remember Ing. We've got our 7 types right here with definitions. You've got notes on your 7 types. These are things that you should be using to help you. So what kind of energy is stored in coal? In the bonds between carbon and hydrogen. What kind of energy was in bonds? Josh, can you help me out? What kind of energy is in the bonds between carbon and hydrogen? You've got the 7 types listed right below the picture. Right down here, you've got the 7 types. Chemical, thank you, sir. So I've got chemical energy that I'm starting with.
Excuse the interruption. Our guests from Chamberlain High School are here. Would these people please report to the library now? Marge Blair, Michelle Verrocki, Casey Stranton, Drew Kraniak, Peggy Klein, Diane Linster, and Laura Heiberger. Grace One Star, Sky Humbert, Jessie Courtier, Gabby Fast Horse, Haven Sneed, and Lee Long. Would you please report to the library at this time?
Alright, so we've got our first one answered. We're changing chemical energy into, or well, we're starting with chemical energy. And look at the picture then after that. It hits a pulverizer, goes around the conveyor, it hits a pulverizer. So we have to, in order to make energy, we've got to do a lot of other things. Right? To start out, we've got to pulverize it. What's pulverizing mean? If something is pulverized, what happens to it? It's gone, right? It's crushed. It's some really, really strong thing. Pencil? Something that uses a lot of force to crush it. And not just crush it, but like destroy it, right? So it gets crushed into itty bitty little things, pulverizing. And then it runs over with the stack, a precipitator, and then what happens to it? What happens to it next? What is this symbol being used for? Number 3 in the picture. What does that show? Fire. So what's happening to it? Burning. So in order to get energy out of coal, first, we've got to get the coal, this chemical energy, crush it so it's in itty bitty pieces, and then burn it. And this is our second question. To release the energy stored in coal, it is burned, right? We just covered that. The combustion means to burn. So the combustion of coal transforms its energy into what 2 types? So we've got the 7 types of energy above there. We already know it starts out as chemical. What is it changed into? What does burning things change it into? Take a second, look at those 7 forms. Heat. Heat is one of them. So it's changed into heat and what? Light. Heat and light. All fire produces heat and light. So that's that thermal energy and light energy, electromagnetic. What is the vessel or the device that is being burned in called? A boiler. When you think of boiler, what do you think that might be used to do? Boil things. Right? If you boil things, if you boil water, what happens? Water gets turned into what? Steam. So a boiler must be used to create what? Smoke? If we just said that a boiler, when you boil water, you create steam, what do you think a boiler's purpose is to do? Make steam. So we have cool chemical energy being crushed, which would be mechanical energy, so we're using mechanical energy in this, not getting it out. And then we burn it, creating thermal energy, heat, and light energy, that electromagnetic, to boil water. So what we're doing right now is we're trying to work on not just getting an answer, but thinking through the answer. So that if I give you something like this, or say you just go out and someone hands you a schematic or a diagram, and they're like, what's going on here? Might not even be with energy, might be with something like a car, and they're like, hey, I'm trying to fix my, my heating coil, and this is a schematic for my car. How do I get in there? What does this mean? You can see it and think through it. Stuff like this can be applied to so many things. So many things this can be applied to. Not just what we're doing. Very useful for energy. Very useful for other things. Whoa, come back. Alright, so it's boiler. Creates steam. Steam goes, and waste product, ash system. So we have crap that we don't want. Steam goes, turns a turbine. But first, third one, the energy produced by the combustion of coal is used to boil water. Right? What we covered with steam, The steam that is produced causes a turbine to spin. So it goes to the turbine, or turbine, depending on what your pronunciation is. Turbine, I believe, is more correct. And it causes it to spin. What is that spinning energy? If it's just spinning, what is that energy of motion, right? If it's spinning, it's moving. It's doing what I'm doing right now. It's moving. I'm pacing, I'm moving. I've got this energy right now. We had chemical, we created heat, we created light. First one, what is it? Mechanical. So that moving turbine is mechanical energy. So you see, we want electricity. We've got a lot of steps that we use every day, that our world uses every day, just to get this to happen for you right now. This light to turn on, this smart board to turn on. So we're getting farther along, and we get mechanical energy, this turbine spinning, mechanical energy. So the turbine is connected to what? What is our next step? Cool, crush, burn, steam, turbine spinning. What's that connected to? What is the purpose of spinning the turbine? What are we trying to get action on then after that? A generator, which is eventually going to give us electricity. But a turbine is hooked right into that generator. You can see we've got a shaft here. So my turbine is spinning. You see these arrows? Meaning that's turning too. So this is turning, and it's hooked right into our generator. So we get that spinning motion, the mechanical energy, shoved into a generator. So the turbine is connected to a large magnet. So when the turbine spins, the magnet also spins. That's the way a generator works. We talked 2 units ago about electricity and how we can have generators. We're seeing it again. So this is an example of what kind of energy if we are spinning a magnet. When you spin a magnet, what kind of energy do you have? Mechanical, thermal, light, electrical, chemical, nuclear, sound. What kind of energy would a spinning magnet be? We got mechanical, we got electrical. Let's take a second and think about it. If it's spinning, have we made the jump to electrical yet? If we're causing a magnet to spin. If I hold a magnet up here and I twirl it and throw it in the air, do I have electrical energy yet? Mechanical. Just because it's spinning doesn't mean we've quite made that jump. It's a good thought process to remember, okay, magnets and wire create electricity, but we haven't really got to the wire yet. We're just spinning a magnet. So we have to be careful to think of just what we have, just what is right there. Still mechanical. We didn't make a transformation. So that is our second to last bullet point. This is another example of mechanical energy. If you're having if you're on a test or something, you have a sticking point there, use the wording. So use what you learned in English class, context clues, which I know you guys have covered in English. What's going on in the words that can help you? In the third bullet point, we had the energy has been transformed into mechanical energy. The next one says the turbine is connected to a large magnet, so when the turbine spins, the magnet also spins. This is another example of. The word another means a second or third or an additional. So if we see this is another example of, we must have already talked about this type of energy. So another example of mechanical energy. So you should be filled in up through those first four. Then, spinning magnet in a generator. Spinning magnet causes a current to be produced in a coil of wires that surrounds it. This is the final outcome of the power plant.